in this example too, you are going to integrate a cosine function, but the cosine function in the bracket is a algebraic term, 2 terms, and in respect of dx. Well, if it was just cos 3x, we could have done that straight away with the conventional method. It's the cos 3x plus 4. Okay, so because of this, we have to, because this is a because in maths, so we need to apply integration by substitution. So they all have this format. Okay, so now we know it's integration by substitution. So therefore, we can get started. What is our first step? Let u equal to, yes. So we're going to let this okay, so I'm going to go to the, well, you don't need to worry about that, you will see. Now, if I wasn't an expert, I just go ahead with all the information I've been given and try and integrate and see what that comes to. If I get stuck, then I will go back and think, have I done enough at the start? So, so we said that u is equal to 3x plus 4. Okay, so I'm going to rewrite this now. So y is equal to integrate cos u dx. So that's the second barrier, because it's a letter u, but I'm integrating in respect of x. We can't let that happen. So we're going to find a way to get dx to change into du, and the only way to do this, if you du by dx, and that will come to quickly, so yeah, 3. And rearrange this. So dx therefore is equal to du over 3. Agree? Yes. Thank you. Okay, so let's put that in now. So we can put this in here. So let me just draw an arrow. So now that goes in here. So that comes to y equal to integrate cos u, and that will be du over 3. Oh, we have a constant. Okay, it's over 3, so let's take it out. So let's take the constant out. So if I just circle this constant and then bring it out here, so bring constant out of the integral. Now you might want to add that in your write-up to make to explain it. Out of the integral. Okay, so we have then a third integrate cos u du. Right, I have that on there, didn't I? So integrate cos x is sine x, but with cos u, so it will be sine u. Yeah. So it's easy when you can look at your notes. I mean, this is interesting when people do exams. So this is the moment in my A-level years, I will say to myself, have I made the right decision to do A-level maths? So I kind of regretted it then when I saw this. So cos u du. So that comes to a third sine u plus c. Well, we finished, haven't we? we just have to do the last bit of putting the u back in it, which was 3x plus 4. So therefore we can now say y is equal to sine 3x plus 4 over 3 plus c. Voila. It's all done. That's it. So you will have questions similar to this. So make sure, don't forget to see, that's what I will be looking for. Have you explained with some wording, and to find, I mean, what you need to write in terms of as you're doing it. So what I don't want to see is just pure maths involved. There should be sentences in between to say what you're doing, and you can find that in your textbook. It tells you the steps you can explain. Okay, so there are actually 3 more ways to integrate, but this is not covered in BTEC. Okay, so this is the 2 integration method you need to do. I mean, imagine one that we haven't covered. What happens then if you have an integration of, say, 2x plus 3 and 4x plus 5? If you have a fraction, what do you do then? Okay, so there is another method for this. So it seems that the book is not doing any fractional type of expression. So until then, that's it. Okay, so the next part is not hard, but it's a different strategy which it needs to be covered. So it's called integration as a summation tool. Okay, so if I stop this recording,